Hello, everyone. Good morning, good afternoon, good night, depending on where in the world you are joining us today. It's my great pleasure to welcome you to the first event at the AI webinar series. We call it Launch and Learn. We will have 4 different talks through this fall semester, but this is the first talk. This event is hosted by the University of Maine AI initiative with collaboration from Maine Communication Society and Computer Society Joint Chapter, and is also co-sponsored by IEEE Region 1 in the Northeast USA. And we are broadcasting live to big entrepreneurial regions in the world, including Silicon Valley in California, Shenzhen in China, Boston in Massachusetts, and Bangalore in India. IEEE USA has been also a sponsor for this event, so we thank everybody who made this event possible. So without further ado, let's get us started on the presentation. So I'm going to introduce our first speaker, Dr. Kaushik Chaudhary from Northeastern University. Kaushik is Professor of Electrical and Computer Engineering at Northeastern University and Associate Director of Institute for the Wireless Internet of Things and a faculty fellow of the College of Engineering. He received his PhD from Georgia Tech in 2009 and MS from University of Cincinnati in 2006. Professor Chaudhary is the winner of the US Presidential Early Career Award for Scientists and Engineers in 2017. Defense Advanced Research Project Agency Young Faculty Award in 2017 as well, and the Office of Naval Research Director of Research Early Career Award in 2016, as well as the very prestigious and competitive National Science Foundation NSF Career Award in 2015. His current research interests include deep learning for wireless sensing and spectrum access, network robotics, wireless RF energy harvesting, transfer and IoT applications for intra and on-body communication. So it's my great pleasure to welcome Dr. Chaudhary to the podium.
Thank you very much, Professor Bedi. Thank you for this opportunity and this invitation to this very amazing seminar series that you have organized. So let me share my screen and okay, so I'm very pleased to talk about some exciting new research that we've been doing on radio frequency fingerprinting, and I'll show you how we are using deep learning in a very interesting way to recognize a specific wireless device from a number of different wireless devices that may be existing in the same space. So it's like finding a needle in the haystack, and you have so many different devices, but can you identify one without looking at their names or IDs? So that's going to be the trick. That's going to be the main premise of this talk. And some of this work is done in collaboration with some of my faculty colleagues, Professors Stratisi Onidis, Jennifer T, and Tommaso Melodia. All right, so let's get started and understand where would you like to use this kind of an RF fingerprinting device identification technique? What's the motivation? So we are living in this world of transformational IoT, and there are various market studies that point to the immense market potential of IoT technologies. And driving this revolution are these number of small form factor, small sensor devices that will be pervasively deployed. And some estimates go up to about 200 billion devices all worldwide. Now, the problem that happens is that when you have such numerous devices, how do you authenticate a device? How do you know that this device is really who it's claiming to be? Well, you may say, yes, each device has an ID, and there are various cryptographic techniques that can assure some sort of a more authenticity of a device. But bear in mind that some of these could be extremely simple, extremely resource constrained, and they simply may not have the computational resource to be able to perform complex functions on a small form factor. So could we identify a device simply by listening to its signals without complex mathematics to encrypt secret keys and so on? So The other scenario that I want to talk to you about is as you go to dense networks and massive deployments of wireless networks, you find there's going to be lots of packets exchanged over the air. And if you look at a standard packet format, and this is what you see on the screen is a Wi-Fi 802.11a MAC header, you see the number of address fields that are within the same header frame. Okay, this is the header frame. It's not contributing useful data, but it is still important. It is part of every packet that's transmitted, and you can see how much of part of this frame is simply address. Now, if you could remove these addresses and compress the header, you find that you can nearly achieve about an 80% compression. That means you're transmitting less control bits over the air. And just to take this one bit further, you can, by extension, by sending less bits in terms of addresses, you can improve your spectrum occupancy. You can reduce the amount of time over which the spectrum is being utilized. You can also reduce the amount of energy that is utilized by wireless devices because they are transmitting less bits. Now, again, the crux of this is that you have to be able to identify a device based on its signals, not IDs. So hence you can remove these IDs. So let me tell you about how do we go about this and what are the tricks that we apply in doing so. So the main trick here is that we want to identify a device based on certain unchanging hardware-centric imperfections that are inherent inside it. And why do these come about? They come about because in any processing chain, you are using a number of different electronic components. They could be capacitors, inductors, transistors, etc., filter banks. And all of these introduce a small nonlinearity in the signal that pass through these components. So you can think about as the signal passes through, the hardware of the transmitter is injecting a signature onto the signal that is then passing out from the antenna. And this is the hypothesis is that this is a very unique signature, which is very specific to each radio. So our goal is to identify a device by recognizing these unique fingerprints that are being imparted because of process variations in the electronics of the transceiver chain. Now, this little plot here shows you an example of what these signatures may look like, right? So our signatures are scribbles on paper, but a radio signatures are basically shifts in the in-phase and quadrature amplitude IQ signals. Now, any signal really in the RF communications domain can be represented as an IQ in the IQ plane. And this is an example of a modulation scheme that has these 16 points out here. Now, in the ideal case, these points should be at the red dots. But because of this hardware fingerprints, these are shifted. And you can see the small shifts shown by the symbols with a plus sign. Now, if you look at the rest of the transmitter chain, you see there's plenty of other components, and each of them can be imparting its independent shift. So you could have an IQ imbalance, you could have a phase noise, harmonic distortion, each of them changing the signature in a certain way. So the goal here is that you want to detect these, and it is hard to do so in a deterministic manner. It's hard to do so because you don't know what to look out for. So you can't hand engineer a specific algorithm that looks at definitely this much amount of shift and map it to the cause of the shift, because these are all superimposing on each other. And for that, we need deep learning, because we cannot exactly pinpoint what is the specific signature in a device, but we can identify that there are signatures in a device. And to do so, we use a technique called as convolutional neural networks within the broad family of deep learning approaches. So in this work, I'm going to tell you, I'm going to give you examples of two different architectures that we have used, and those are based on AlexNet as well as ResNet. Now, these architectures have been proven to be remarkably successful in image processing and image classification tasks. And these are always among the winners of annual image classification competitions. But we thought that could we take the same architecture and modify it just a little bit and apply it into the completely different RF domain. And so there are different advantages of these two different architectures that you see. The first one, baseline, it is not as deep as the ResNet. It does have more parameters, but it is not as deep as the ResNet. And it has, as you can see, 10 convolutional layers, 5 pooling, and 3 dense. And you don't have to really follow exactly what each layer does at this point. It's not that important. But the takeaway message is that the baseline is quicker to train. The ResNet takes a lot more time to train, perhaps days sometimes. But the reason why we can do a much deeper architecture in ResNet is because of these skip connections. As you can see, these little lines that join the input to the output. And what this happens, the way this happens is that when you train a neural network, you're generally using a technique called as backpropagation, and you're propagating the error at the final output back through the chain and making corrections in the weights of the neurons, right? So if the architecture is too deep, these gradients diminish, and the effect of the gradient, the correction that you can apply, diminishes with layers. But with the skip connections, that effect is reduced, because now when the gradient has to go back, it can jump across these layers and go back and not be diminished in its impact. So this is just an example of two different architectures, and we have seen good success in both of these. Now, I'm going to tell you about how we have tried to use some of these in practical scenarios and in real use cases. So the first one is an example where we want to identify a base station from multiple other base stations. So think of future 5G networks where a base station could transmit different kinds of waveforms. Different kinds of vendors could be using the same hardware over time. And your goal is to identify that, yes, this hardware or this base station is transmitting, and you want to do that in an agnostic manner of vendor ID, of protocols or waveforms that the base station is transmitting. So here in this example, we have used an experimental testbed, a platform called as the Powder platform. And this is a family of platforms that comprise the platforms for advanced wireless research, which is a major initiative started by the National Science Foundation, and then in collaboration with a number of companies, they have put together a $100 million cash and in-kind contribution pot in which we make platform awards. And these platforms are built in live environments, in cities, in communities. And so here is one example where you see in Salt Lake City, Utah, we have a number of base stations. You can see these base stations shown in these little icons out here with the snowflake sign. And we have a passive receiver, and the goal of this receiver is to identify which base station is transmitting by simply hearing its signals. So you may say that, okay, we apply those architectures that I showed you, the baseline and the resonant architecture, and even if we use different sorts of transmit waveforms, including Wi-Fi or LTE or even 5G NR, you find that we do very well in identifying 4 base stations on the same day, if we train and test on the same day. But if we take those same data from day 1, and then we get another data set on day 2, that means train and test on different days, the accuracy drops, because the takeaway is that apart from the core hardware signature, the wireless channel is also impacting our classification accuracy. So we are not completely being able to remove the effect of the wireless channel. So we have done a number of different methods and tricks to solve this problem, including data augmentation, through which you make a signal go through multiple different variants by injecting noise. We have also learned automatically the channel using a second convolutional neural network that estimates the channel. But here I'm going to talk to you about a method which is called as Siamese networks with triplet loss. Now the word is big, but it's really very simple. All we are trying to do is we give one example, which is an example of a true class. That means a true base station. In this case, let's say a tiger, right? And Next time, we also give it a positive example of the same class. That means also a tiger. And we look at the features that are being learned by this neural network just before the final output layer. And so this is something like, let's say, it abstracts a rough feature representation that it is able to obtain from these inputs. And ideally, because these two examples are from the same base station, or in this case, the same animal, the same tiger, you want to minimize this loss. And in a different example, I will give it a negative example. That means I'll show it a cat, and I'll say that you want to maximize this difference that you are learning in this penultimate layer. So you minimize the difference between features from the same example class, and you maximize the difference that you're learning from examples from different classes, right? And all this can become part of a separate loss function. So you take that loss function, you combine it with a regular loss function that you use anyways to train a neural network, and you find a combined loss function. And when you do that over multiple different iterations, you find that you can truly learn a unique representation of the animal, which is actually devoid of some of the background noise, some of the background effects, which should not affect your final outcome. So the bottom line is, whether I show this white tiger in the forest or this classical orange and black striped tiger on the stones, you should still be able to detect this is a tiger. And of course, differentiate from these cute cats, which are playfully looking at you. You have to avoid that urge. They are not the same. Now, when we apply this triplet loss technique, you find that, well, this is the same plot taken from the train and testing on the same day. This is our benchmark. And you find that when we apply our triplet loss, we can do much better. We can do about 93% because now we have made the architecture more robust to these variances. I'll give you another example. One of the growing problems that we are facing today is UAVs are being used extensively outside. And it's often a question on whether this UAV is legitimate or whether this is malicious, especially if the same model is being used by hobbyists or by malicious actors. So what we want to do is, the UAV is always hovering, and that is contributing to a more complex channel. So we want to make a little bit a different strategy here. We want to inject a custom signature onto the UAV. And here are different examples by which you can inject custom signatures. You can inject DC offsets, IQ imbalances. Here's an example of what you see when you inject a DC offset. You see a high power at the 0 frequency mark at the DC level. And similarly for IQ imbalance, you see an image frequency that emerges at exactly at the mirror image position. So the trick here is to inject some of these imbalances in a controlled manner, thereby making the signature unique. So here is an example that you see. If you can actually inject this signature, you find that the classification accuracy is perfect. As you can see here, in the orange line, you're doing very well with the signature injected. That means now you are making the device become someone else. You're injecting a unique signature to a device. So I just want to conclude by saying is that data sets are key. If you are interested in this area, you must look at ways to extract good, meaningful data sets. I gave you an example of the power platforms, and you can extract a number of different kinds of RF data sets from software-defined massive MIMO, full duplex, millimeter wave, UAVs, and so on in different power platforms. We also have the world's largest RF emulator called as the Colosseum, by which you can create virtual worlds. You can create malls and as urban environments and rural areas. And all of these can be emulated, and you can collect rich data sets. And especially this should be critical to generate good data sets for good machine learning. All right, with that, I'll stop here. And thank you again for this opportunity to present this talk. Thank you again.
Thank you very much, Professor Chaudhary, for the interesting talk. So you basically heard one of the applications of deep learning in recognizing wireless devices. So if you're interested to learn how you can get funding to work on projects like this, you are here for a treat. We are very honored and excited that we have one of National Science Foundation program directors here with us today. So our next speaker, Dr. Rebecca Hua, is an associate professor in Department of Computer Science at the University of Pittsburgh. She received her BS in Computer Science and Engineering from UCLA in '93 and her PhD in Computer Science from Harvard University in 2001. Her recent research focuses on understanding persuasion from a computational linguistic perspective. Some of her recent projects include modeling student behavior in revising argumentative essays, identifying symbolism in visual rhetorics, and understanding idiomatic expressions. Dr. Hua is the recipient of the prestigious NSF Career Award. Her work has also been supported by NIH and DARPA, and she is currently serving as Program Officer in the Computer and Information Science, SICE for short, at the Engineering Directorate at the National Science Foundation. So while Dr. Hua is sharing her slide, just want to remind everybody that you can put your questions in the Q&A section, and we'll have all the panelists today at the end of the presentations to answer those. So without further ado, Rebecca, please take it away.
Thank you very much. It's a pleasure to be here. Today I am here in my role as a program director rather than in my usual role as a researcher and professor at Pitt. So at NSF, I've joined as a program officer last year. So I've been at NSF for about a year. It's a rotating position, which means that in another 2 years' time or so, I will probably return back to University of Pittsburgh. If you have interest in becoming a program officer, I'm also happy to answer questions about that later on. But right now, today, my main focus is to share with you some of the opportunities that we have at NSF for artificial intelligence research. Let's see if I can actually turn the slides. That would be good. Great. And so there are many, many opportunities throughout NSF for AI-related research. It's probably not possible for me to enumerate all of them all at once. So I mainly hit on a couple of highlights, in particular, the National AI Research Institutes, which is a relatively new program. And so I will spend probably most of my time talking about that, especially because we have a new solicitation that just went out. I will also talk a little bit more about the core programs within IIS, that's my division, for information and intelligence systems. And then within that core program, there are 3 core programs within IIS, and I belong in the robust intelligence program, so I will spend a little bit of time talking about that as well. And then I just, for examples, I will mention 2 additional cross-cutting programs, the Smart and Connected Health, as well as the Future of Work at the Human Technology Frontiers. Like I said, there are many, many more, even going beyond the directorate of size into other directorates such as engineering or the SBE, Social Behavior Economics Directorate. So please do see our webpage for a more comprehensive list of opportunities and links to solicitations and so forth. So first thing I wanted to talk about today is the National AI Research Institutes. This is a relatively new program. We just finished our first year, and then we have a new solicitation out as of last week. So this is pretty exciting for us. We also just made the announcement for the first round of institute awardees. So I wanted to spend most of my time kind of plugging for this program, if you will. This program is set up to, in particular, to address relatively long-term projects focusing on AI-related topics that are of national importance. And this came about because there was a meeting back in 2016 and then updated in 2019, where we have where a plan was made for the National AI Research and Development Strategic Plan, where the #1 priority was to make long-term investment in AI research. And as a result of this meeting, several federal agencies got together and proposed this program. And so the initial participants include the Homeland Security Department, the Department of Transportation, NSF, of course, and USDA NIFA. For this upcoming year, this new solicitation year, we also now have participants from the industry sector, including Accenture, Google, Amazon, and Intel. So the goal of this program is to, of course, significantly advance research in AI. But in addition to that, we also want to see these advances become developed into transformational AI-powered innovations in other sectors. It's important for these AI institutes to promote a strong workforce so that we will have a steady pipeline of future AI researchers and practitioners. Importantly, these institutes are set up to become national nexus points for universities, federal agencies, industries, and nonprofits. So we're looking for multi-organizational, interdisciplinary efforts. The program structure is set up as cooperative agreements for 4 to 5 years, up to $16 to $20 million for each institute. And these institutes should be addressing one of several identified themes in the solicitation. They change from year to year, but these themes are basically chosen based on a number of considerations, including funding opportunities, community readiness, and just kind of general interest in terms of national priorities. So here is an image. I know it's pretty small, so you can't read all the fine prints, but this is the result of our first 7 AI research institutes from year 1. These focused on 6 things, including trustworthiness in AI, the foundations of machine learning, AI for agriculture and food, AI for augmented learning, AI for molecular and synthesis, and AI for discovering physics. And so aside from the food and agriculture one, which has 2 institutes, each other theme has 1 institute. And you can see in the image that they're spread out across the country. Many institutes have a wide network of partners, so even they're kind of color coordinated, so you can kind of see that they're spread out across the country. And we're looking forward to a new year of solicitation. And in this upcoming solicitation, we want to encourage institute proposals focusing one of these following 8 themes: human-AI interaction, AI Institute for Advances in Optimization, AI and Advanced Cyber Infrastructure, Advances in AI and Computer and Network Systems, AI Institute in Dynamic Systems, and again, AI Augmented Learning, and then AI to Advanced Biology, and again, AI-driven innovation in agriculture and food systems. The proposal deadline is December 4th, so just a few months away. We have a webinar planned for answering more questions the communities may have about these various themes and the program in general. And the webinar and registration will be probably late September. The detail will be posted at the program announcement. So if you're interested in thinking about submitting, please do check our website for our program description for the exact date and how to register. Now I want to switch gear a little bit and talk about our core programs. IIS is a division within SISE. And so our division focuses on activities having to do with research and education that are related to AI. And this is sort of the bread and butter of everybody's research efforts. So we have annual solicitations for proposals to our core programs, as many other directorates and programs divisions do. Our programs, we solicit for small projects and medium projects. Small projects are defined as up to $500,000 for up to 3 years, while mediums are considered everything above that up to 1.2 million and up to 4 years instead. The mediums have a specified deadline of November 12th. While the small, from now on, actually, we're trying out this no deadline idea. So you can submit anytime as of October 1st. And so the sort of programs that we have, my home program is the Robust Intelligence Program, where we accept proposals having to do with foundational research for understanding and developing systems that can sense, learn, reason, communicate, and act. And so typical topics include machine learning, which is the set of projects that I oversee, but also automated reasoning, computer vision, human language technologies, knowledge networks, integrated autonomous systems, and computational neuroscience. There are other programs that are also related, including the Information Integration Informatics, or III program, where their focus is really on data. So innovative research in data science, and they cover topics including databases, data management, all the way through multimedia and applications of data science to science engineering and society. So you can see that if you have a machine learning oriented project, you might consider robust intelligence if it's core machine learning oriented, or if it's more data mining, data discovery oriented, you might consider something like III. And then finally, a third program within our division is the Human-Centered Computing program, which has to do with human and computer interactions taken broadly. And this could include everything from interfaces to assistive and accessible technology, technologies with social impacts, and so forth. So there's a wide range of interest about various topics within AI, within our directorate, and also outside of the directorate. And so one of the major focuses within NSF is to have cross-cutting programs that partner with both their other directorates within NSF, and also programs that partner with outside agencies. The Smart and Connected Health program focuses on integrating innovative computer and information science engineering approaches to support the transformation of health and medicine. And this one is partnered with NIH, as well as the engineering and SBE directorate. And then finally, I'll just mention also the Future of Work at the Human Technology Frontier program, another cross-cutting program. This one focuses on science and engineering research set in a context of the frontier of work. So you can see that the topics can be as widely varied from kind of clinical decision support to firefighting to geoscience research to manufacturing. So it really covers a great swath of efforts. And with that, I will stop here. There are many, many others, as I said, and I encourage you to take a look at our website for additional opportunities. And if there are questions that I might answer, I'd be happy to do so later. Thank you.
Thank you very much, Dr. Hua, for a very comprehensive overview of National Science Foundation programs. So now that you heard from academic sort of areas, problems, you learned about funding agencies, I would like to remind everybody that IEEE one of the largest technical professional societies in the world with over 450,000 members, has one of its missions to connect academia and industry together. So we are going to hear the industry perspective next. And we are excited to welcome Fawzi Bahman, a visionary and a thought leader, author, and contributor in advancing adoption of technology in serving humanity, to the podium next. And while Fawzi is loading his presentation, I would go over his brief bio. Fawzi has over 35 years of professional and leadership experience in communication and networking areas in product development, marketing, and services at Freescale, Nortel Networks, and Teleglobe. He was chief architect in building national telecom network management and participated in the development of ITU TMN M3000. In 2009, Fawzi founded Telnet Management Consulting Company, offering consulting services in the area of disruptive technology positioning, 5G, IoT, and of course AI, and implementation of a smart solution development. Fawzi is a senior member of IEEE, distinguished lecturer, and IEEE Communication Society Regional Director for North American Board in 2020 and 2021. He also chairs several society chapters in the past and has organized several conferences as well. Fawzi holds a Bachelor of Science with honors and distinction from Concordia University, Montreal, Canada, Master in Computer Science from the University of Waterloo, Ontario, an executive MBA from Queen's University, also in Canada. And before Fawzi starts, I just want to remind everybody that please continue entering your question in the Q&A. And after this presentation, we'll go through the question and answers. I know this is lunchtime for some of you and maybe dinner time for others. So please be reminded that if you want to leave the presentation, that's perfectly fine. We'll post the recorded version of this later on the University of Maine AI website. So without further ado, Fawzi, the floor is yours.
Thank you very much, Professor Abidi. And hello, everyone, everywhere. It's the pleasure for me to share with you some of the experience I have, especially from industry perspective, and touching on the whole arena of telecommunications and AI. So the agenda for the next few minutes is really looking at certainly the operations, the way it was or decades ago will be quite a bit different because of the acceleration of technology and in particular disruptive technology. So we'll touch on how this disruptive technology is going to impact in particular telecom. We'll look specifically at a use case for an international carrier and understand some of the issues that were present at that time, and look at how AI and network management for telecom can have a wide and greater opportunities for future for research and deployment of intelligent solutions, and then end up with taking away. So in terms of disruptive technologies, I picked up the ones that really have crossing all the vertical markets. In particular, certainly we hear a lot, 5G has started this year, commercial deployment, and we see the vast capability in terms of superiority, in terms of technical performance, whether it is in latency, lowering it from an average today of 40 milliseconds to 1 milliseconds. We see it in terms of throughput, going from 100 megabit per second to 10 gigabit per second per connection, as well as in terms of overall connectivities with the IoT, covering maybe in a span of 10K per kilometer. Now it's going to about 1 million connection per kilometer. And of course, in terms of mobility, you can still have maintained services, but with a higher speed. So if you are on a higher speed train where that can go to 500 kilometers per hour, you still maintain receiving signals and continue operations. So that's a nutshell in terms of capabilities, but above all, we'll see later on that 5G is actually enabling and empowering a lot of vertical markets. So that's something different than other previous generations. By contrast, the IoT market itself, from the beginning has greater attractions. And we could see that from revenue perspective or market size from back in 2017, $110 billion, and today it's $248 billion. And if we look at 2025, looking about $1.5 trillion. So that's a continuous growth. And as mentioned previously in one of the talk, I mean, we're looking about over 200 billion types of connection by that time frame. AI, by contrast, is a little bit lag behind the IoT, but nevertheless, it has a very positive and future growth from revenue as well as traction perspective, from $7.1 billion in 2017, going up to 223, up to $98 billion by 2023. By contrast, we could see easily, if we look at 223, since we're talking about, you're seeing about 8 times more in terms of size of market IoT compared to AI. Blockchain is also coming in and will have a greater impact also in the telecom arena, and it is growing in a much healthier way from 1.5 billion to 2018 to 15.9 billion in 2023. And special in major area, of course, in terms of billing and finance, but also healthcare and agriculture. Now, translating what I mentioned earlier, that 5G is really like, to me, is the glue for all the IoT and also empowering along with AI to really deliver a much more effective type of network. So, but effective network really across wide spectrum and in terms of use cases and vertical markets. Both 3GPP standard group as well as ITU have tried to visualize the impact and where 5G could penetrate. So we're seeing the triangle. You have on top is enhanced mobile broadband as one group. The massive machine type communications, typically empowered by IoT, and the ultra reliable and low latency type of communications for all types of mission critical, self-driving car, augmented reality, et cetera, et cetera. So these types of use cases really will take time as 5G will come to mainstream. Today we see it deployed in the focusing more on the enhanced mobile broadband and into fixed networks, and then more towards the massive IoT, and then more in terms of mission critical over different releases. So what I want to touch upon is really touching all of us as we are in different regions in the world. What tie in between one and the other is really global administrations in every country, whether it is people that are in Shenzhen, and you have the service provider back there, and as well as those in India, Bangalore, and so on. They have their service provider. Those in Canada, they have theirs, as well as those in US have theirs, and so on in different regions. So here's an example of, had the privilege to work with the international carrier in Canada called Teleglobe. And as you could see here, all these networks for facilities and carrying traffic, these facilities could be two types. One could be fiber optics under the ocean, Pacific or Atlantic, or it could be international satellites around different geographical locations. And essentially, that's really what being symbolized in this particular globe. There are 3 levels of operations, differently at the transmission area, where at the edge of the country itself, where you have the satellite-based stations and cable stations. And as information going back or forth, you have central locations in the country called International Gateway for transmission and switching. And then overall supervisions and from advisory perspective, as well as analysis perspective, you have the Network Control Center and Network Analysis Center. So since I spent many years at Teleglobe, I had the opportunity to watch and observe how everything is done from beginning And I was given privilege to be part of the corporate task force and built up a program for network management. And then I was asked to put a staff in to implement it. So essentially it took multiple years, but nevertheless, we structured in a way to have systems at the at the station level, whether it is cable stations or satellite stations. We had also systems put in the international gateway, and we have an overall supervisory system put at the network control systems. As you could see, for facilities at satellite base stations and cable stations, you wanted to have tractions on all these equipments and tap into the equipment and the systems to be able to see the health and conditions of these systems as they are carrying traffic from one end to the other. Back then, there are some, you call it maybe rudimentary compared to the today's terms, whether it is things like RSXXX, 485 and so on, or sensings that could be analog or digital. But you have an overall element management system that has been developed at each of the stations. At the gateway is a bit different because all of the informations that are criticals are being captured and sent out to the gateway. And the gateway really have a major functions here because it does locate where the fault are, what the impact on the fault in terms of traffic and revenue, does quite a bit of analysis, maybe does a bit of reconfiguration or rerouting, as well as look at the overall performance and SLA agreement with different administrations. So it does a whole series of activities, and it does major things in terms of timestamp of acknowledgement of faults and also issuing control, and exercise these things based on ITU TMN function, telecommunication management network function, M3000 standards. And then the overall supervisor is done by the network control center with more graphical world display of where issues are, where the trouble spot, where the heavy traffic is, and so on. This is just give you a bit of the background behind having in each level the associated set of nodes and computing power and software that was all developed in-house, and also the leased line facilities connecting the stations with the gateway, and then from the gateway to the network control center and various images that, that can be shown around. But this one is not done in isolation because we dealt with over 250 administrations, and all of them have the same type of approach, except we wanted to jump ahead and we used state-of-the-art standards, which is the TMN, and based on those functions, the 5 major functions, we followed the ITU TMN standards, which I had the privilege to work on the standards development for about 4 years of being part of the Canadian delegate at that point. And we're able to really use that as a state-of-the-art use case for others administration that they were able to come and visit and see what we have done. There is a lot of complexity and a lot of hard work. Everything is behind all that is a lot of wiring and engineering field staffs to do things like circuit order that takes several months and so on. All of these things nowadays, if you jump forward multiple 10, 20 years, you can do these things with SDN and NFV in really minutes, or so the things that takes months and months is really being now automated with can be much easily automated. So therefore, I want to make a contrast then. The ITU TMN standards could resemble quite a bit of the model that we're working with. And for every systems, you need to have means of sensing and getting information that are critical for the operation of a given system and communicating that information to then the next layer, which is now transitioning to be more processing towards the edge of the network as an edge computing and aggregations, and applying some AI levels at this point and provide some feedback in terms of control or send critical information for history and analysis, and going more for in terms of deep learning and insightful information and trends. So certainly we have witnessed quite a bit of challenges in terms of the way things were done physically is now moving more towards the virtual with infrastructure. We saw the AI will play a key role into that, but AI is also going to support and help in keeping key performance indicators and service level agreements being maintained in a more efficient fashions. And if we look at the next slides, essentially we see that AI and ML have a huge impact over in network management. This slide itself showing a lot of work being done, especially in areas such as in blue, in terms of network operations, monitoring and management, which I touch on quite a few of these, the customer service and service level agreements, and a number of other things. On the left-hand side, you see a number of areas, certainly the whole arena of sensing and impact in terms of traffic and customers and revenue and priority of service is an important AI-based type of network configuration now with SDN and NFV and others to be able to help to achieve a higher level of virtualization for rerouting, recovery, or even expanding the network itself. Also in terms of maintaining quality of service and performance and facilities, and also contractual agreement, such as in the SLA agreement, and also in the whole arena of security and fraud mitigations and communication with other administration in terms of rerouting of spare facilities between one administration to the other in terms of overflowing the traffic to another administrations. That can all be done supported with AI and of course the blockchain engagement in various things we do. At that time at Teleglobe, we were doing reconciliations of all billing across Commonwealth type of countries, and blockchain would have been a great handy usage for that. So in conclusion, then the takeaway is really we continue to witness both on one hand the explosive growth of technology and specifically disruptive technology as we have gone through at the beginning, but we saw the emergence and the interception with AI, ML, DL will become quite useful and handy in supporting and transforming from not dealing just with symptoms of the problems, but really going down deeper into the root cause of a given problem, getting insightful information and make the right decision that maintain a higher healthy revenue projections as well as efficiency in terms of operations. So overall, we see AI have a greater impact and open up door for multitude of opportunities in terms of network management for all administrations worldwide. With that, I thank you for your attention. If there are any questions, we'll be happy to respond to. And here is also my contact information. Thank you.
Thank you very much, Fawzi, for the great presentation. I would like to thank all the three speakers again, and please turn on your webcams, Kaushik and Rebecca as well. So I'm going to ask some of the questions. We had a lot of questions here. Some of them will be answered and posted later, but I will just pick a few of those so we can answer those live. So I will start with Professor Chaudhary, a question for you. Is there any standard that define what an IoT is? And I have seen companies calling anything IoT. Is that acceptable?
Well, it's a good question. You know, it's like an elephant. Which part of the elephant do you touch and call it IoT, right? But I take a holistic view. The way I see IoT as a paradigm where devices are interacting with each other, with humans, with the environment. And in that connected plane, if there is information being exchanged, decisions are being done, sensing and understanding of the environment that is being increased, then that is IoT. And you can slice it in different levels, protocols, you can do analytics, you can do just device design. These are all verticals that enable this holistic view of IoT.
Thank you very much. So next question is for Dr. Hua from NSF. So one of our attendees are asking that, are these NSF programs focused on engineering and software design aspect of AI, or is it open to the humanities as well?
Right, that's also an excellent question. Well, so we are the National Science Foundation, and so certainly many programs have a strong science and computer science and engineering flavor to them, but that doesn't mean that we aren't interested in cross-cutting efforts, and in particular interdisciplinary, multidisciplinary research. From that perspective, especially many of these topics do touch on societal issues. Computational social science and also digital humanities certainly could have a perspective that contribute to a cross-cutting team.
Thank you very much for answering that. Next question is for Fawzi. How do you see the recent 600 megahertz frequency sale by the FCC versus 5G? And which do you think will have a bigger impact in the short and the long term?
Yes, I think from a spectrum perspective, I would see perhaps 600 megahertz will have a good traction in the market and adoption and deployment. But there's still, as we go through the spectrum for 5G and then 6G coming along, they're increasing that frequency to be able to handle more precision and more lowering the latency and achieve much greater type of results.
Thank you very much. And there is a lot of questions regarding the recording, and I just put a link in the chat that you can go to ai.umaine.edu to see the recording of these presentations. And we will also post the answer to some other questions that we didn't have enough time to respond to here. So we still have a few more minutes. I'm just going to go another round and one more question that we can answer. So I'm going to ask the next question from Dr. Hua regarding the human-centered computing. So do you foresee some HR corporate departments expanding into the role of intelligent resources departments, integrating human resources and artificial resources integrated and fielding teams of tuned combination of HR and AI resources?
So I guess that's a forward-looking question for some not as of yet quite ready technology. You know, it's the future, so it's hard to say. I know people are working on problems of that nature. I don't know if they necessarily would be considered, well, I mean, I guess it is human-centered in a way. But I think the important thing there is to focus on how, if one were to do something like that, how to do so without bias, without without ethical issues. And I think that's a very challenging problem for the future.
Thank you very much for answering that. And the next question goes to Professor Chaudhary. Being a Utah native and knowing how varied our weather is, has this research begun to utilize weather interference and its effect on the unique RF detection?
Well, certainly true. So if you're talking about being able to detect an emitter in a variety of different environmental conditions, there are some things that we can do, in a sense that there is some things that we can do from a learning point of view. We can use data augmentation. We can use extensive creating machine learning systems that can identify channels that change over time. So we have some tricks up our sleeves that we can do that. But from the other side, if you're talking about experimental deployments of systems themselves and how does weather affect them. So I showed you some data sets. They are collected from the power testbed. That is actually, the devices are in temperature controlled settings and they're enclosed in with a specific engineering done to protect the devices from market deviation from their nominal values. So there are both the things that we do. But certainly there are tricks using machine learning and data analysis itself where we can overcome small fluctuations over time.
Thank you very much again. So I would like to start closing the event. We only have 1 minute left and we don't want to go beyond this. Just want to remind you that every first Thursday of the month at noontime Eastern US time, we'll have a series of AI webinars similar to this one. Next one will be on applications of AI in business, industry, government, healthcare, and environment, October 1st. And in November 5th, we're going to have education and workforce development panel. And December 3rd, we have social, ethical policy, and legal consideration. So if you want to sign up for those webinars, again, look at the chat, ai.umaine.edu. I would like to thank our Office of Vice President for Research and staff members who have been helping us behind the scene to make this run smoothly, as well as IEEE sponsors. And a very hearty thank you to all the speakers. I know all three of them are extremely busy. We are definitely very fortunate that they were able to join us in this busy time. And thank you all the attendees for signing up and listening to this. My name is Ali Abedi. I'm Assistant Vice President for Research at University of Maine. So any criticism you have, anything went wrong, you can blame me, but I would like to thank everybody who was behind the scene, UMaine IT and staffs that they run this event. So thanks again, everyone, for joining us, and we hope to see you on October 1st in our next event. Have a great day, everyone.